Hello, welcome to the class. Um, so actually, last time it was like that. The video was not so good, so that students complained about the sound and the quality of the video itself. So I need to give you back some review of last time. So I think actually I forgot what I have done that day, so I need to check first. Um, it looks like it looks like um, we have done we have done a okay. Let me open up the IPython first because I really have no idea what I have done last time. Last time I no bunt I plant and the lab anyway. So cool. No, okay. Okay. So let me check what I have done last time. So last time what I made was that upstream block and expression cluster. So I checked the expression level of this study, and this study was consisted with some days. I think I selected the days to have some good clustering of the samples. So it looks like that 8-day and 9-day is kind of early stage, and 14, 13, and 15 and 16 will be late stage. And you can see the clustering is happening very well. So maybe the other way we can say this is where no. So this is clustered. Yes, this is a right clustering one. So this is a right clustering one. This is early clustering one. And we have filtered the data with regard to the expression if every expression is 0. So if every expression is 0, then your summation of them will be 0. So I don't want to have everything is 0. So I made the filter mask, and according to mask I filtered the data. And the data filtered is scaled. So what is scaled? Scaled is some kind of function, the definition that it changes it into Z-score. So the reason why I made it into Z-score was that I remember that it is not well clustered at that time. So I tried to make it well clustered so that I apply the scale. The scale is a function for making Z score. And the X is applied to the data frame, and I clustered. And the visualization was like this, and I made y value indicating that this 2 is early stage and that 4 is late stage. So x values is assigned only having the values, and I fit the data into the y. So early and late stage, right? So random forest is applied, and then I check the distribution of the feature importance of random forest and find that okay, I can use this threshold to have only few genes, right? So these genes, right? So these genes very well dividing the stage, right? Early and late stage. And then I check the genes, the selected genes based on the index value. So this is all index value, right? And I reclustered using original value using standard scale 0. So this was just score, and standard scale used the min-max normalization. So rather than just z-score, it used min-max normalization. So it provides you more distinct visualization compared to the z-score. Okay, and then the selected genes is applied to the data filter that we originally created. The filter was the data was filtered by the summation of the expression, right? So it do not have any genes that only express 0. So I selected I applied whether it is up-regulated or not, right? So if you just click on the up-regulated, then true or false is labeled. So your data frame will be like this. So I retrieved the Tiffany information, but it was I thought that it was not so necessary for the analysis. Yeah, so Tiffany was not so necessary. Only data frame feature to count was necessary to retrieve um, the block information. Wasn't right? So feature to count. Feature was the block, right? So I think I can just run this one. I want to import. So I want to, let me see, import. So import pan.spd. So yeah. So the feature was the block. So feature was the block, and we tried to make the random forest based on the label. So we selected gene set that is up-regulated or down-regulated. So that was the label. So can we extract what block is so important to predict whether this is up-regulated or not? So that was our question, right? So can we predict the expression of this gene based on this profile? So we could predict it is up-regulated or down-regulated. So let's see. Based on based on these blocks. So we do not know what is the counterpart of this block. So some of the counterpart will be some kind of transcription factor, or the other additional protein complex, or secondary structure of among them. So we do not know the mode of action, but these blocks are very important to, what was that? To predict it is first. What is first? First means that it was down regulated. Okay, so if there is some information of them on the upstream sequence, then you will predict it will be down regulated. Interesting, right? So this is the last week's not last week's analysis. Okay, so it was really interesting. So this result actually, from expression. So expression is coming from certain environment, right? So what is the meaning? So environment, I mean, these blocks are very important when you have that environment. Is it right? Anyway, so if you have different set of data, then you will grab another block. So what I'm thinking is that if you can grab everything, I mean, if you can grab every RNA-seq expression data, for example, you might have RNA-seq data, many RNA-seq data of heat stress, or if you have many RNA-seq data with short stress, or if you have many RNA-seq data with cold stress, then you will have different set of promoters block. This is very interesting. So then, as far as you have many data, then you will have many candidate promoter sequences. Then if you have the database of them, then the other researchers can use the information very well. Okay, so this was the last time analysis. It was not that difficult, but we had really bad situation of the recording. I don't know why. Hopefully today we have right quality of the video. So see you again.